Good afternoon. Welcome to Math Realm, where math is simplified to its fullest possible way. All right, today we will be looking at the root of quadratic equation. And in this root of quadratic equation, at the end of the class, or this class, if you will be able to, I really plead with you, you should stay. Yeah, we will be solving the following problems. I would like us to solve this problem. We have if alpha and beta are root of the quadratic equation. Find I, the sum, alpha plus beta, I, the product, alpha, beta, given the following equations you have. I'm going to solve some of these problems, and I will leave some for you to try. Don't hesitate to drop on my comment section if there is any that you find it very difficult using following technique I gave. I will drop the solution of every problem that I'll give, so that as you're solving, you'll be looking at the solution at the end of this class. We will also solve this problem, construct and simplify equation whose roots are, we have I minus 3 and 1, I square root of 3 minus 2 and square root of 3 plus 2, I 1 over 1 plus square root of 2, and you have this pair of coordinates. And then the last one, the sine square and the cos square. We will solve that, and we will solve this also. I am very much interested with this problem. When I got this problem from a text, I saw this problem from a text. I get so very much interested. I think from additional mathematics uh by Jeff Talbot, Gottman, G.A.O. Ogum. So in case you are familiar with this, if you check these problems, you will see the following problems that I'm stating there. If you have that text there. So I am so seriously interested with this problem. It looked very amazing to me, and I would like us to look at it critically as I'm going to solve this one also. Then I will leave this last one for you to try, but I'm going to drop the answer at the end of this class session. So I would like you to don't fail to subscribe to the channel because it's coming back again in full energy. Um, please don't fail to subscribe to the channel, and like and comment is to make you to also see whenever the new content is being dropped, and as well as boosting up my channel as well, because it's just not really a new channel, it's just that it's a channel that is trying to come up. Okay, generally speaking, a quadratic equation is any equation of the form ax squared plus bx plus c equals to 0. And for any quadratic equation, maybe in x that I'm using right now, we have that a is the leading coefficient, in case you don't know. We have the leading coefficient or coefficient of x squared. Then b is the coefficient of x, and c is a constant, also known as the y-intercept. If we are to plot in a graph, you see the c appearing at where the curve passes through the y-axis. So, but that's not what we want to talk about today. For any quadratic equation like you can see here, excuse me. Okay, sorry. I'm trying to put my charger. My system was really not doing well. All right. So for any quadratic equation, we call this, I think, a standard way of writing a quadratic equation. There are other ways of writing quadratic equation, but this is a standard form. Okay, for any form that you find quadratic equation, the solution of quadratic equation is always given by x equals minus b plus or minus square root of b square minus 4ac all over 2a. Wow. If you don't also know this, you can check some of my content. I think I derived this, but if I did not, I think I'll create a content on that. So the solution of this equation as it is this thing. Don't forget that A is the leading coefficient, B is, or you can just call it coefficient of x squared, but I love to use the term leading coefficient. So B is the coefficient of x, and C is a constant, or most time calls the y-intercept. For now, let's just call it a constant, equation constant. All right. So this equation, because of the plus or minus, is telling us that the solution of a quadratic equation most times are two, like there are other pairs, or there are double, like two solutions always resolve. Most time, although these solutions mostly sometimes can be the same, but a quadratic equation always generates two results as the solution. And this solution of this quadratic equation, as we can see here, is what we call the roots. So we can either call it solution, you can call it the root, you call it solution. If we are talking in terms of polynomials, we can call it the zeros of the polynomials. You can call this the zero of the polynomial. So you can call it the solution, you can call it the roots. So solution here is the same thing as the roots. All right. So because of the plus or minus, I want to write this equation with respect to the sign of the plus and minus that you are seeing there. So, and I want to look at it this way. I want to say if alpha and beta are roots, remember, if I say root, I'm referring to the solutions. So are roots of this quadratic equation. So that means we can write this solution as, you can say alpha can be equals to minus b. I can decide to use plus square root of b squared minus 4ac all over 2a. And then I can write beta as minus b. At this time, I'm going to use minus square root of b squared minus 4ac all over 2a. So meaning that these two alpha and beta now can be called the solutions of this quadratic equation, because I say it is in two ways, the plus and the minus way. Okay, so in this context, what we are going to do here is I'm going to show you that there are ways we can manipulate the equations, the solution of this quadratic equation without actually looking at solving the problem itself. So I would like to rewrite that solution again. I would say, but this time I would like us to take that b squared minus 4ac as d. It is always called a discriminant function. So, but right now we don't have interest for the name. Just let's call it d. So that means if I write alpha to be equals to minus b plus or minus, plus, I'll say square root of d, divided by 2a, and then beta, the other solution, is minus b minus square root of d all over 2a. Now, we want to get the sum of this root. We have to get the sum of this root. Let's see what the sum of this root will be equals to. So I will say alpha plus beta is going to be equals to minus b plus minus square root of d all over 2a plus minus b minus square root of d all over 2a. So, and if I evaluate that place out very well, the LCM of 2a and 2a must always be 2a. So I'll write 2a. Then everything on the numerator will be the same. Minus b plus square root of d plus and minus is going to be minus. So we have minus b minus square root of d. We collect like terms. By collecting like terms, that will give us plus square root of d minus square root of d. So let's write it close to each other. We have minus b plus square root of d minus square root of d divided by 2a. Of course, you can literally see that this and this will go. So that will give us minus 2b all over 2a, which this and this will also cancel. And that will give us minus b all over a. Fine. So what do we bring out from this? It means that for any quadratic equation, the relationship between the way we sum the roots, that the sum of this root is also as we can take the ratio of the coefficient of b all over the leading coefficient, the negative ratio of that. So the sum of the root is like the negative ratio of the coefficient of x all over the leading coefficient. So that we can say that alpha sum of root of quadratic equation is equals to minus b over a. Okay. Similarly, if we take the product alpha product of roots, let's see what will happen then. Alpha times beta will be equals to minus b plus square root of d all over 2a times minus b minus square root of d all over 2a. Okay, and that will give us, remember that is binomial on top there, so that will give us minus b plus square root of d close open bracket minus b minus square root of d divided by 2a times 2a will give us 4a squared. All right, so that will give us this solution as minus b times minus b will give us b squared, and then we will also have if you look at that critically, that is different of two squares, because minus b plus square root of d and minus b, so we can go ahead and say that will be the same thing as minus square root of d all square all over 4a square. I'm just using different of two squares there. So you can carry out the expansion, that is what you will have. And if you open that bracket, you will have b squared minus d. Remember, I said for simplicity, let's write that expression for d like d. So the d was equals to, don't forget, d is the same thing as b squared minus 4ac. So I will write this as b squared over d over 4a squared, which I will write it as b squared minus bracket, because an expression, b squared minus 4ac over 4a squared, which will be the same thing as, if you open this bracket, you will have b squared minus b squared minus times minus, inside there we have positive 4ac divided by 4a squared. This is 0 here. So we are left with 4ac over 4a squared. Now 4 can cancel 4. A will cancel itself. 1 time cancel the square, remaining 1. So what we have left there is c over a. It means that the product of the roots is given us alpha times beta whenever we product the root is the same thing as the ratio of the constant term over the leading coefficient. This time positive. Okay. Now I will say that these are very important formula or identities that we brought out here. Let me write it out here. So that the sum alpha plus beta is equals to minus b all over a, and then that the product alpha times beta is equals to c all over a. There's something I want you to see. Let's rewrite that quadratic equation again and divide all across by a. So if I write, recall that the quadratic equation is ax squared plus bx plus c equals to 0. I'm going to divide all through by a, all through by a, like the leading coefficient. If I do that, I will have ax squared all over a plus b all over a, then x, then plus c all over a equals to 0 over a is still going to be 0. So for clarity, let me still do it there. So if I strike this out, you have x squared plus b all over a x plus c all over a equals to 0. Now, if you look at this, the only difference between this is that I can say if I multiply both sides of this, let me call this equation 1 and call this equation 2. I want to do a proper substitution into this place. But before I do that, I would like you to take a look at what I'm going to do right now. This is what I'm going to do. I will say if minus b over a is equals to alpha plus beta, then it implies that b positive over a by multiplying both sides by negative will be equals to minus into alpha plus beta. Good. So I'm going to do that substitution, meaning instead of me writing this, I'm going to write this. So I'm going to replace that equation with what you have there. I will say that x squared minus bracket alpha plus beta, then, which is the same thing as this, then x, then plus, then alpha beta, which is equals to 0. I call this the quadratic equation in solutions. So quadratic equation that is built with the sum of the solutions and the product of the solution. You can give it any name of your choice, but I love to call it a construction of quadratic equation using the solutions. So meaning that if we divide across a quadratic equation of any kind by the leading coefficient, what we are doing there is that what we are obtaining there is we have the x squared minus the sum of roots, then x plus the product of roots. Both of them equals to 0. That's what that means. So how does this help us to solve some couple of questions? We will look at that at a glance. So I would like you to look at it critically again, because that means it can be used to form a quadratic equation itself, where the quadratic equation comes from. If you can know the value of the alpha plus beta, or whether you know the value or not, if you can know the coefficients and the ratio value, then if you substitute them, you can form a quadratic equation of which these roots come from. That's what I'm saying. Okay, so let's see how true that is. Right now, let's look at this problem. It's time to solve the problem. I am going to solve one of this problem, and you will also solve the other one. So I would like to start with a very simple one, and then I'll strike this one. Then I'm going to give you the answer that you have for this one is that the sum of the roots alpha plus beta, if you solve it properly, should give you, I think that's the second one, will give you minus square root of 3, and alpha beta, the product, should give you 1. Like if you are doing the right thing, the sum of the root will give you the minus square root of 3, and the product of the root should give you a positive 1. I will not solve that one. I'll leave it for you to go and try yourself. Also, for this one, I would like us to deal with it personally. Okay. So solution. Let's look at it. Having the quadratic solution for A, having the quadratic equation x squared minus x plus 1 to be equal 0, if you look at it, the leading coefficient A equals to 1, B equals to minus 1, and C equals to 1. And we obtained earlier that the sum of roots equals to minus B all over A. So that means the sum of roots alpha plus beta sum of root equals to minus B all over A, which is the same thing as minus into minus 1 all over, that is the minus coming from the formula, and the B itself, which is minus 1, I'm putting in the bracket, then all over A, and A is equals to 1, and that will give us positive 1 over 1, which is equals to 1. Similarly, product of root alpha beta equals to C all over A, and the C is 1, and the A is 1, and the result is 1. Meaning that the sum of the roots is equals to 1. And the product of this root is equals to 1. All right. Let's continue. So for the C solution we have solution of C. The question is 2y squared minus a plus 3 of y, then plus a squared equals to 0. A lot of students love to stay away from problem because we have some terms that are not numbers, I want to tell you that you should take it exactly as if you are dealing with ordinary numbers. So in this case, A equals to 2, that is the coefficient here. Then B equals to minus bracket A plus 3, because that's what is attached to Y here. And then C is equals to A squared. So what do we do? To alpha plus beta, therefore, alpha plus beta equals to minus B all over A. That would be minus into minus of A plus 3 close divided by 2. And that minus into minus, they will give us plus. So we have A plus 3 all over 2. That will be the sum of the roots. You can't go further than that unless you want to split the fraction, which does not really make any sense. But if you want to do that, this is what it will be. You can still write it as A all over 2 plus 3 over 2. Still correct. All right, product of root alpha dot beta equals to C all over A. So this will be equals to, the C is A squared all over the A is 2. So you can write this as A squared all over 2. Another way that you can write this is also A over square root of 2 all squared, but that does not really matter. If you drop it this way, it's still very correct. Okay. So these are the possible questions that you will mostly sometimes see in this field of problem. So the another one that I would like you to look at critically is this other one. So you are given roots. This time alpha is given, beta is given. So solution for I, that's the first one, alpha is equals to minus 3 and beta is equals to 1. Meaning if you have the root, how can you form the equation? Whose that root is coming out from? Okay, so how you do that is this. For example, alpha, you can decide alpha for 1, beta for minus 3, or alpha for minus 3 and beta for 1. It doesn't really matter. So before you solve this, I would like you to recollect something. Remember, we form a equation that says that x squared, the relationship between roots of the equation and the equation itself is that the equation is made up of x squared into the sum of root alpha plus beta of x and the product of root plus the product of root equals to 0. So for any quadratic equation, it is in this pattern, provided the leading coefficient equals to 1. Okay, so if you do the substitution into this equation that you're having here, the required equation will be obtained, and you have minus, you have x squared minus bracket minus 3 plus 1 x plus bracket minus 3 times 1 equals to 0. So we have x squared, then we have minus into minus 2x, then plus minus 3 equals 0. Finally, minus to minus plus, we have x squared plus 2x. Now 2x there, then minus 3 equals to 0. So this is now the quadratic equation where that root or those roots are obtained from. Don't forget what I said. If you have any doubt about any of the solution, you can do well to also ask some questions on my comment section. I will do well to break it down for you where you did not understand. Okay. Similarly, if you do for the second one, I would like to do for the second one, then I'll leave the last one for you. I'm going to give you the answer to this one, A and S, that the equation that you will have from here is going to be uh, x squared, for example, is going to be x squared plus 2x and minus 1 equals to 0. So I'm telling you that that is what we'll have from this other one here. If you do it properly, you have x squared plus 2x minus 1 equals to 0. That is the equation that this will form if you do it very well. So I will do this and this, and I think I should also give you the answer to this one. So you go try it yourself. Yeah, A N S, or what you have from here, the equation is going to be x squared, for example, x squared or minus 2 root 3x minus 1 equals to 0. If you try that very well, that's exactly, that's what you should see. Exactly what you should see. Okay. So let's move to the last one right now. I have serious interest for the last one because of some couple of things that happened there. So solution for the D, solution D. Alpha equals sine square theta. Beta equals cos square theta. And then we know that the equation of the roots is generally given as alpha plus beta sum by x plus alpha beta equals to 0. So if you do this, you have x squared minus bracket sine square theta plus cos square theta close bracket x, then plus sine square theta cos square theta to be equals to 0. From identity trigonometry, which I'm not going to prove this with our subsequent classes, you will see that this identity equals to 0. I mean equals to 1, sorry. So I would just write it for clarity's sake, but sine square theta plus cos square theta is equals to 1. So what we're having there is x squared minus 1 times x and plus sine square theta cos square theta equals to 0, which you can readily write it as x squared minus x and plus sine square theta cos square theta. But there's something I want to do there. Take a look at. Some people may likely want to drop the answer at this point, but I don't really like the answer to be at that point. Let me take your attention a little bit to trigonometry, and then I'm going to put that answer in another form, which will make sense much better than that. Remember, if we have sine A plus B in the compound angles of trigonometry, the sine of A plus B is always equals to sine A cos B plus cos A sine B. That's this multiplication. So if A equals to B, both of them equals to theta, you have sine theta plus theta, that is 2 theta, equals to sine theta cos theta plus cos theta sine theta. I'm trying to bring something here. So which it will be equals to 2 sine theta cos theta. Now you see something like this coming out here. So if I divide both sides by 2 here, I will have 1 over 2 sine of 2 theta to be equals to sine theta cos theta. Now, if I square both sides of this, if I say 1 all over 2 sine 2 theta all squared, that will give me this side also being squared, which will be the same thing as sine squared theta cos squared theta. And if I open this bracket, I'll have 1 over 4 sine squared 2 theta sine squared 2 theta to be equals to that expression there on the right hand side. Okay, meaning this equals to 1/4 of the square of this 2 theta here. So instead of me writing it like this, I would love to put this place like x squared minus x, then plus 1/4 of sine square of 2 theta. So that if I multiply, I mean, all of them equals to 0, 0. So that if I multiply everything, I don't want to see the fraction, you will have 4x squared. Let me look at that again. I will have minus 4x, then plus sine square 2 theta to be equals to 0. All right. So, and I would like my quadratic to be in that form so that if you check the right hand side here, if you check the right hand side here, and if you look at all the parameters in there, you realize that everything there is constant. So if I say that let everything there be k, that means I can simplify the equation as 4x squared minus 4x, then plus k to be equals to 0, which really resembles the equation we are talking about here. So you can see that that problem is not really hard that we thought. You have to understand this concept properly. All right. So please don't forget to look at it again and again and again because it's going to make a whole lot of sense here. Okay, lastly, the problems I long for, I told you I have serious love for this problem. And I would really like us to reason together when it comes to this problem. Because of this problem, I've on my GeoGebra from my search engine and click because I'm going to do some couple of things here with you, and then I believe it will make sense here at the time we will be solving the problem graphically so that you also see. The problem says the line L equals to y equals to mx meets the curve C, which is x squared plus y, this equals to 9 at 2 points A and B. By substituting y from L, this here, into C, okay, into the curve, and then we obtain a quadratic in x whose roots are the coordinates of A and B. So we will obtain those roots and see what the value are. Then hence we want to show that in the diagram that what we are doing is really true, that OA is the same thing as OB. Okay, where O is the origin. So I would like to start this problem like this. We have solution. We have the line L, which is y equals to mx. We have the curve C, which is x squared, I think, plus 4y squared equals to 9. Let me confirm that. Yes, x squared plus 4y squared equals to 9. Please don't forget that it's not a circle. When I put it on my GeoGebra, I realized also that it's not a circle, but it's circular, but it's not a circle. That must be an ellipse. All right. The question said we should substitute, meaning any place we see y, any place we see y, in the C, we will replace y with this value of y that we have in the L. So the C is, we have x squared plus 4y squared equals to 9. So that will be x squared plus 4 bracket open mx. Since y in L is equals to mx, then I'm going to square it because y in the C has a square on it. So equals to 9. So by the time we open this bracket, you will have x squared plus 4 m squared x squared equals to 9. And x is common, so I can write it out as x squared into 1 plus 4m squared to be equals to 9. Look at it very well. Now, what we have here, if all of this is something like k, so that means what we have here is kx squared equals to b. So that means there is no middle term. It could be that the solution, oh no, they are asymmetric in nature, but I don't want to talk about that yet. So let's get, if this is true, then it simply implies that x squared must be equals to 9 divided by 1 plus 4m squared, so that the value of x itself must be equals to plus or minus because of the square and because of the quadratic nature of the square root of 9 all over 1 plus 4m squared. That means x is equals to plus or minus 3 over square root of 1 plus 4m squared. Wow. So remember, we mostly use alpha and beta to denote these different roots because these are two roots now. We have two roots here right now, the one with the plus and the one with the minus. So let's alpha equals to 3 all over square root of 1 plus 4m squared, and let beta equals to minus 3 all over square root of 1 plus 4m squared. These are the two roots. So why do we do this? Because I want to have the corresponding coordinates. Coordinate is a set of order pairs. So we have the x coordinate and the y coordinate. So if I'm to try to sketch this problem. Remember, I said earlier that this is going to be a kind of, it's going to be a kind of oval, ellipse, like this. And then we will have a coordinate system inside this. If I try to get that right. So okay. So trying to get a coordinate system inside of that, we go back to a pen. I'll get something like this. Oh no. Forgive my drawing. Okay, so you have the positive y, negative y. So we have the origin O, positive x, and the negative x. So this is the C curve. So I can decide to pass like this. Let me use another color. I decide to pass like this and say this is my L curve. And I can call this point A and call this point B. So the symmetric property here is that we want to prove that from here, this distance from this point to this point B is equals to from this point to this point A. So the coordinate system will have, let's say, x1, y1 coordinate values. And here we'll have x2, y2 value. Or if you like, you can call that the alpha and the y1, and maybe the beta and the y2. So that's what I'm going to show you right now, very soon. I'm going to show you again somewhere. So we want to know how symmetric it is. So if this is how I want to do my own, if this is symmetric, if this place is true, that means the distance from here down here must be equal to the distance from here to here. And then the distance from the origin down to this place here must also be equal to the distance from here to the origin here. So if this is true, then we have a symmetric triangle or a similar triangle in this context. And if these two sides of this triangle are the same, definitely OA and OB is going to be the same, which we will solve that using distance between 2 points, O to B and O to A. So with this little idea, I'm going to now go into solving that problem. I would like to substitute the value of y, of x, or let's call it alpha, when alpha equals to, let's say, 3 all over square root of 1 minus 4m squared. I believe that's true. Alpha equals to, okay, plus that. Then beta equals to minus 3 all over square root of 1 plus 4m squared as well. So we'll substitute it into our y equals to mx and see what the value of that will be. Corresponding for alpha, when alpha equals to this, we can say the y value for the alpha, let's call that y alpha. Y alpha will be equals to m into 3 all over square root of 1 plus 4m squared. And that will give us 3m all over square root of 1 plus 4m squared. Similarly, the y beta, the y value, the vertical values, this is y beta, is also going to be equals to minus 3m all over square root of 1 plus 4m squared by substitution. Remember, y equals to this. Y equals to mx. So replace this value of alpha, which are the value of x, solution plus minus, remember? So into this place, we have this value. Now look at it. Let's go back to the diagram. So this is the y. So this is where the y alpha, okay, let's change here to alpha. Let's change this bx for this point, represent beta value. This x for this place represent alpha values because I'm using positive there. So that means the distance from here to here represents the y alpha value, which is equals to positive 3m equals to positive 3m on all over square root of 1 plus 4m squared. And the distance from here to here equals to y beta, which is equals to minus 3m all over square root of 1 plus 4m squared. Look at it. Now, this is negative x-axis. So the difference is just the direction. The minus here, but here is plus. And let me show you another thing again. Remember the x value, sorry, I call it x2 or the alpha value. This is where the alpha is. The alpha value at that point is equals to 3 all over square root of 1 plus 4m squared, meaning that the distance from the origin to this place is that. Similarly, the beta value for this place was given as 3 minus all over square root of 1 plus 4m squared, the same value. So they have similar values in their representation, meaning that the distance from here is equals to the distance from here, and the distance, vertical distance here is equals to the vertical distance here. So we can say that this right angle triangle we're having here is a similar triangle, a similar right angle triangle that making sense. So what if we want to solve, what would be the value of OA? So, or OB. So the distance from O to B must be equals to square root of the x2 values or the alpha values, that's distance between 2 points. So the change in the x value, which is the alpha values, okay? So we have x2 square plus the y2 square. So by substituting into that place, you will have the x2 value. The x2 value was given as 3 all over square root of 1 plus, I wish I can go a little bit higher from here. So you have the x2 square and OB equals to the x2 square plus the y2 square. That's distance formula. By substituting, you have 3 all over square root of 1 plus 4m squared all squared plus, now the 3m all over square root of 1 plus 4m squared all squared, because those are the value of the y2 and the x2, or you call that the alpha and the y2. Sorry, the alpha and the y alpha. That is the notation I was using in case you may want to ask. So this will now give us, the square of this will give us 9 all over the square of the square root is the value inside the square root, 4m squared, plus we have 9m squared all over 1 plus 4m squared, which will give us 9 square root of 9 into the LCM denominator here the same, so into 1 plus m squared, bracket close, divided by, we have the LCM of 1 plus 4m squared is 1 plus 4m squared. So if you also find the value of the OA distance, that will be equals to, from distance formula, equals to the x1 square plus the y1 square. So remember, I use this place to be beta value, and I use here to be the y beta values. So substituting into, you will have minus 3 all over square root of 1 plus 4m squared all squared plus minus 3m all over square root of 1 plus 4m squared. Okay, so simplifying, you have square root of, you have 9 all over 1 plus 4m squared plus 9m squared all over 1 plus 4m squared, and that will give us the same thing. Look at it, the same thing. So we have that will be by 9 into 1 plus m squared over 1 plus 4m squared. Now, if you look at the result that we have in these two aspects here, these two results are the same. So therefore, we can conclude that the distance OA is equals to the distance OB. That's exactly what they were looking for. That's exactly what they were looking for.